Hi, I'm Andrea Meyer with Working Knowledge, and I'm here at DSCC 2011 with Cedric Simard, who's in charge of the IceDream project for Dassault Systems, and we're going to be talking about what that project is, which is very exciting. So first I'd like, Cedric, to ask you, can you tell us just a very quick overview about what the IceDream project is?
Well, in just one sentence, Andrea, the aim of the project is to tow an iceberg from point A to point B and to turn it into fresh water. It has been a 40-year-old idea, and we've been collaborating on this project with George Mougin. He's a French engineer. He's about 87 years old today, and he's been working on that project for over 40 years now.
Well, that's very exciting because I was reading a little bit about background that he really came up with this idea 40 years ago.
True.
And had no way to kind of bring it to fruition or show his idea earlier. So your technology in Dassault Systems is helping actually bring that idea to life. Can you tell us, did you find him? Did he find you? How did you get together?
Okay. Well, the first thing you have to know is that at Dassault Systems we have a corporate program, a corporate sponsorship program, which is entitled Passion for Innovation. And the idea behind that program is quite simple. If you, Andrea, why not? If you get an idea, a very innovative idea, like using iceberg to produce fresh water, and if you're passionate about the idea, which means that you have a certain level of skills or you've worked a certain number of years on your project. And third thing, if you do not have the means to test your concept or to develop it the right way because of lack of means, well, we will help you. We will provide you with the modeling and simulation technology that should demonstrate that your project is feasible.
Wow, so this is called Passion for Innovation, and is it open to any kind of entrepreneur, scientist who might have that kind of wild idea to explain to you and see if that would be a project that would be worth collaborating on?
Basically, yes, it's open to anybody as long as the person is a non-profit person or working in a non-profit organization. So it works for students, for retired people, why not, or whatever, whoever.
So this is interesting. So this idea about taking an iceberg from Newfoundland and transporting it down to a location that's kind of water deprived was very, very interesting. What kinds of things Dassault kind of modeled, I think, kind of showing how the feasibility of this would be possible. Can you tell us a little bit about some of the simulations or the technology that kind of helped bring this to life?
Yes, for sure. Well, actually, you just think about the project. You're capturing an iceberg around the coast of Newfoundland. You protect it so that it doesn't melt too fast by using a giant floating belt, then a giant skirt, insulating skirt, then a giant net, as used for tuna fishing, by the way, and then you tow the iceberg up to your destination point, which is, in the case of our prototype project, which are the Canary Islands. If you just think about that project, that's exactly what we did using virtual and digital simulation technologies. We recreated a whole world, a whole virtual world around the berg, and we took into account real data, real oceanographic and weather data to simulate the sea currents at several depth levels, the winds, even the sun rays. And doing that, you can just click the button, run, and before that, you'll select the number of boats you want to use. Let's say 1, 2, 3, 4, I don't know. You'll select the departure date, you click run, and you'll see how it goes. And basically, it looks very similar to Google Maps, if you will, when you're looking for, a certain destination for your vacations, I don't know. Instead that you're towing an iceberg, and in the same time you'll be able to monitor the oil consumption, the ice loss, and the time also, which goes by, and that's about it. Well,
wow. So basically, you're taking into account all these different factors of what the ocean current is going to be, the wind, temperature, all of that, kind of creating a virtual world to simulate, how would this behave. So were there some things that you found out that were surprising in terms of, I don't know, how much it would melt or how long it would take or those kinds of things?
Yeah, we had some surprises. George Moulin was pretty much confident about his project because before meeting us, he did analytical studies, but still he didn't know to what point it would work. And we had some very, very nice surprises or very unexpected behavior of the Berg convoy. Let me give you just one very concrete example. In the ocean, there are what ocean experts call eddies. They are giant whirlpools. They can be like 200 or 300 miles wide.
Wow.
That's really giant whirlpools, eddies. What happens if the Berg convoy just meet such an eddy? The simulation will tell you.
Oh.
Two options. Either the eddy takes you to the right direction. As such, you don't want to do anything except using that towing force. This is a natural towing force, which means that you will be kind of in an eco-friendly mode towing, which is very good. The other option is that the eddy takes you the wrong way. The simulation will tell you. So you have to know this, and you have to anticipate this to avoid such eddies. These are only two very concrete examples of what simulation can bring to such a project, getting lessons learned before going into the real world.
And does the simulation help you understand risks as well in terms of, I don't know if it's possible for the iceberg to somehow crack or something, or get, I don't know, something happen along the way, to take those factors into account as well?
Yeah, for sure. You can simulate just anything. Like you're doing crash test for cars. You could do a crash test for icebergs, but it doesn't really apply to the project. Why that? Because George Moulin will be very careful about selecting the most appropriate candidate. And by this, we mean a very specific type of berg, which is called a tabular iceberg. Tabular because it has the shape of a table, very stable, very regular. And those types of iceberg are not open to any kind of fracture. So, first thing. Second thing, before going into the real world and doing the operation, George Moulin will need to kind of radio wave the berg to see if there are some maybe air pockets within the berg which could create a fracture or breakdown. If there is, this is not the right candidate, forget it. So, but still, we simulated an iceberg breakdown using our SIMULIA software. Yeah.
And were you able to learn how much energy it would take to move this giant iceberg such a distance, how to make that feasible?
Energy, yeah. We measured the quantity of oil for a very precise iceberg, which is 7 million ton tabular iceberg. It would take about 140 days to go from Newfoundland to the Canary Islands, and the berg convoy would consume about 4,000 tons of fuel. What you have to understand is that the real towing force is not provided by the boat. Actually, the very key idea behind this project is to use sea currents as giant conveyor belts, You see? So it doesn't matter your weight. I mean, you got a certain weight, I got mine. Those people over there have a different weight. The same. I mean, when you're walking on a conveyor belt in the superstore or whatever, will arrive at the same time at the other end of the conveyor belt. It works exactly the same for the berg and the sea currents. So you're really taking profit, taking advantage of natural forces like the sea currents, but also the wind.
With all the data that goes into creating these simulations, had the entrepreneur already gotten this data? Do you pull data from different scientific databases? What goes into creating one of these simulations?
Yeah. How can you just recreate the real world in a virtual world? That's your question. Yeah. I mean, any modeling and simulation experts? No, but the man in the street, he has many questions about that. You're right. And actually what we did, we wanted the virtual world to be very close to the real world. So we contacted some expert companies who are in charge of monitoring oceans, weather forecast companies also, and they provided Georges Mougin and us with the right data so as to build the appropriate simulation. So we got a huge amount which do correspond to a year-round amount of oceanographic data to understand how the sea currents works, the swell, and so on, and also weather data. So, and we put all that data into a big box, if you will, and the algorithm, I'm talking about the simulation, the intelligence within the simulation just looked at those data to understand what were the weather conditions on the convoy route and so on,
Yeah, wow. Powerful software to be able to take all this, create it, and create this lifelike experience. And
this is lifelike. And it is truly powerful for one very important reason. Once the model is ready, once you've worked for a certain amount of months, maybe years on certain project, to get the model ready, you only need to select that very precise variable or factor, parameter you want to test. You select it, you click run, and 2 minutes afterwards, you get the result. So you can just play with it like a scientific video game, but it's real. It tells you how the operation would work and how the convoy would behave in reality.
Wow. Well, thank you very much. This has been so exciting to hear how Dassault Systems has shared their technology and kind of creating this 40-year vision and kind of simulating and showing, hey, it's possible. This is a way to bring water to where places that need it. So
Georges Mougin has been a very passionate guy, working on his project for over 40 years, and now thanks to the power of simulation and digital world, he can see what should happen when he will launch in reality. And this may be, I don't know, but this may be the very start of a very new type of industry exploiting icebergs.
Great. Well, thank you. And there'll be more on the Dassault Systems website. You can actually see some of this simulation in real life. So thank you very much for taking the time to be with us today.